Welcome to PatMap. PatMap is an all-in-one intelligent patent data extraction platform. It can automatically extract key information from complex patent PDFs, including chemical structures, full text tables, SAR data, and reaction routes. It also transforms scattered information in patents into structured R&D data that is manageable, verifiable, and reusable. Users can directly drag and drop or upload PDF files. Up to 6 files can be uploaded at one time. Before starting recognition, users can select parsing modules based on their needs. These include structures, coreferences, SAR tables, and reactions. After selecting the modules, click Start. The task will be processed automatically in the background. When the task status changes to completed, click Load. Then users can enter the results page. The system enters the structure view by default. This view includes the molecule list, PDF preview, and recognition details. PatMap supports linked interaction between the PDF and the results. Click a Recognize Structure box in the PDF. The panels on both sides will automatically jump to the corresponding molecule. Select a molecule from the list. The PDF and Details panel will also locate it at the same time. In this way, each structure result can be traced back to the original document for verification. In the original structure comparison area at the top right, the recognized structure and the original structure are displayed in the same orientation. This helps users check whether the recognition result is accurate. After verification, users can directly copy the SMILES or MOL data. If the recognition result is incorrect, users can also edit the structure or use the reselection tool to correct it. At the same time, the lower right area displays structure properties extracted from the original text. These include molecular names, molecular types, and other information. For a large number of structure results, users can quickly locate molecules by serial number. They can also use the filter function to filter results by molecular name, molecular type, and other properties. Identical structures can also be merged or split. This makes it easier to manage duplicate structures. In addition, Structure Search supports substructure, similarity, and exact search. If any fragments are missing, users can click Add Structure and select the missing part directly in the PDF. After verification, the structure data can be exported as SDF or Excel files. Switch to the table view. PatMap automatically extracts tables from the full PDF. By default, the system displays activity tables. Users can also switch to view all tables. In the table list on the right, each item corresponds to a table in the original document, showing the table number, location marker, and table grouping number. Click any table on the right. The PDF area will automatically locate the corresponding position in the original document. This makes it easier for users to compare and verify the result. Click View. Then users can enter the table detail page. Here, multiple sheets are available for different processing results. We will highlight clean data and match data. Clean data shows the cleaned and standardized table content. The system processes multi-level headers, complex headers, and multi-column tables. Match data further links the table data with molecular structures. Based on compound identifiers, the system matches table data with molecules in the structure view. It also adds information such as SMILES, names, and structure indexes. At the same time, both table content and column headers can be edited directly. After editing in clean data or match data, the related content will be synchronized to the other table. Users can also right-click the table content to copy, insert, or delete rows and columns. If the structure information is updated later, users can click Map to rebuild the corresponding relationships. After review and organization, users can export the table data as needed. They can export all tables together or export a single table individually. Switch to the SAR view. In patent documents, experimental data for the same molecule is often scattered across different pages and tables. For example, activity, half-life, permeability, and other results. PatMap organizes data around each molecule and aggregates these scattered data into one view. Each row corresponds to one molecule. It displays its structure, name, and multiple experimental results in one place. At the same time, these structures and experimental values remain linked to their original sources. Users can click a structure or value to quickly return to the original PDF location for verification. At the top right, users can update the SAR results. They can also use display columns to select the experimental fields they want to show. When there are many fields, users can switch to full screen mode for easier viewing. After review and organization, the SAR data can also be exported. Finally, enter the reaction view. PatMap automatically collects the synthetic routes from the patent. Each entry clearly displays the reaction equation and automatically extracts reaction descriptions, reagents, and solvents based on text information. Click the reaction equation, and the PDF area will synchronously locate the original text, and vice versa, achieving seamless comparison. If the automatically recognized reaction is inaccurate, you can modify it flexibly, whether adding or deleting reactants and products, or replacing reaction arrows and adjusting reaction conditions. The operation is very flexible. To manually build a synthetic chain, click Add Reaction. You can directly click Recognize Molecules in the left PDF to fill them into the reactant or product boxes with one click. It also supports manually framing new arrows, and finally supplementing reagents and condition information before saving. After verification, all reaction routes can be exported with one click. From complex patents to clear data, PatMap turns structures, tables, SAR data, and reactions into verifiable and reusable RD data, making patent review more efficient and RD decisions more evidence-based.